Hello. I can prove segments or angles are congruent by proving triangles are congruent and using CPCTC. Very important lesson. This is the culmination of everything we've been doing for the past couple weeks. I'm always first proving triangles are congruent, and now from there I'm going to be able to prove segments or angles are congruent using CPCTC. So let's develop this for you for a little bit here. So I'm telling you that these triangles are congruent. If I'm telling you that these triangles are congruent, that means that the triangles are exactly the same. So wouldn't it make sense that these triangles are exactly the same, that AB would be congruent to DE? That BC would be congruent to EF? That AC would be congruent to DF? I see it come out well. And then wouldn't it also make sense that angle A is congruent to angle D? That angle B is congruent to angle E? And that angle C is congruent to angle F. If the triangles are congruent, that means that they're exactly the same. And if they're exactly the same, that means that all those corresponding pieces are the same. So why? What's the reason? How can we put this into words? So let's say A, B, and DE, for example. Why are these congruent? Well, they're corresponding parts. They're both the left side of the triangle, so that's called corresponding parts. The corresponding parts of congruent triangles. So if they're corresponding parts of congruent triangles, they must be congruent. So if I have triangles are congruent, I could state that any of the corresponding parts are congruent, and the reason corresponding parts of congruent triangles are congruent. For short, we say CPCTC. So to prove segments or angles are congruent, first I need the triangles to be congruent, and once the triangles are congruent, I can state any of the corresponding sides or angles are congruent using CPCTC. So we mentioned our song. Let's go back to our song. Let's hear our song now that we talked about CPCTC, and then we'll see how to do a proof. So let me go to Schlansky.com, YouTube. Let's go to videos, playlists. This is Common Core Geometry. Boom.
Prove triangle, prove three things. For segments or angles, many proofs. Additional tools. DRIAS. Diagram and circle theorems. If you get stuck, please, 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 please make something up.
All right, so, and that last step, if you get stuck, make something up. We'll talk about what that means. Obviously, we don't want that ideally, but if you know how the proof ends and you can't get to your third thing, we can make something up, keep on going. We'll talk about that as we go through. All right, so number one. Prove triangles. Prove three things. I'm always proving triangles are congruent. Is it obvious which triangles I'm proving are congruent here? I'm going to go with yes. I got the green and I've got the blue. So To prove triangles, I need to prove three things are congruent. So I start with my mini proofs. I don't know why I wrote number 1 twice. BD bisects angle ADC given. I do a mini proof with that. That's an angle bisector. Creates two congruent angles. So D is the vertex of what's being bisected. Those are my two congruent angles. D is the vertex of each. Angle ADB is congruent to angle CDB. So it's a little messy. It's a little too messy. I want to fix that. Angle ADB is congruent to angle CDB. An angle bisector creates two congruent angles. I have one pair of things congruent. I need three. I go to my next given. AD is congruent to DC. Given. That's a gift. I mark my picture. I move on. I have two pairs of things congruent. I need three. I'm out of givens. So when I run out of givens, it's time to go on to my additional tools, which for now is just V and R. We haven't talked about IAS yet. We're going to look for vertical angles and reflexive property. Which do I have here? I have reflexive property. So I'm going to state that DB is congruent to DB. Reflexive property. Now that I have my three things congruent, great. Now I can state that the triangles are congruent. I'm always proving triangles are congruent, so make sure that you're telling me that the triangles are congruent, whether or not they say to. Now, what's the reason? Well, let's look at one of the triangles to really get something fancier than my little heart. Let's look at just the green. I see two sides and one angle. Is the angle between them the one that's marked? Yes. So that is SAS. Now that the triangles are congruent, that means that the triangles are exactly the same. So now that the triangles are congruent, I can state any pair of corresponding sides or angles are congruent, so I choose the one that it gave me, that's asking for. AB and BC must be congruent because CPCTC. In the song, CPCTC for segments or angles. If you're being asked to prove a pair of segments or a pair of angles, the reason is going to be CPCTC. If those triangles are congruent, then all the corresponding pieces are congruent. That's why AB is congruent to BC. And again, CPCTC stands for corresponding parts of congruent triangles are congruent. That CT stands for congruent triangles, so I must have the triangles congruent first. And that's why the song starts with prove triangles. You're always proving triangles first. To prove triangles are congruent, you need to prove three things congruent. To do that, mini proofs, additional tools. Let's try another one. Let's try number 5. Prove triangles. Prove three things. CPCTC for segments or angles. Prove triangles. Is it obvious which triangles I'm proving congruent here? It is to me. I see this one. I see this one. So, many proofs. I take my givens, I do many proofs. NO and HA bisect each other. Given. Those are lines. So a line bisector creates two congruent segments. So, since NO and HA bisect each other, they're both being bisected. So if NO is bisected, NC is congruent to CO, and HA is bisected, so AC is congruent to CH. All right, I have two pairs of things congruent. Bisect each other is great because I get two things out of it. I need three. I have no more givens. So I move on to my additional tools. Additional tools, V, R, I, A, S. For now, it's just V and R, vertical angles or reflexive property. Those are the only two things you can conclude without a given. Which do I have here? I see vertical angles. So I state angle NCA is congruent to angle HCO, and my reason, vertical angles are congruent. Now that I have three things, I can state the triangles are congruent. Triangle NCA is congruent to triangle OCH. The reason? Well, take a look at just one of the triangles. Let's look at the blue one. Again, this heart is supposed to be blocking the other one off so we can focus on the one that we're looking at. And it doesn't matter which one we look at. I see two sides, one angle. The angle that's marked is the angle that's between the two sides. So that's side angle side. Now that I have the triangles congruent, I can state any pair of corresponding side or angle is congruent. So now I can state that NA is congruent to HO because of CPCTC for segments or angles. And that's it. Once the triangles are congruent, I can state that any corresponding piece must be congruent, any corresponding side or angle, and the reason is CPCTC. If those triangles are exactly the same, then NA and HO are exactly the same because they're corresponding parts of congruent triangles, therefore they're congruent. That's it. Do I want to go over one more? Sure. Want to go over number 8? Number 8's a little, on the tricky side, just not procedure-wise, just because. So I'll go over it. Prove triangles. Prove three things. So is it obvious which triangles I'm proving are congruent here? It is to me. I've got this one, and I've got this one. So I need three things. I start with my first given, IE is parallel to RN. Given. So when you see parallel, extend your parallel lines, extend your transversal, 8 dots, boom, boom. Are they both in, both out, or one and one? Well, the green one's inside the parallel lines, the blue one's outside, so it's 1 and 1. So those are corresponding angles. So parallel lines cut by a transversal create congruent corresponding angles. Angle IAR is congruent to angle, that's PAR. is congruent to angle HES. If you're not comfortable with that, go back to the video on parallel definitions. All right, one thing down, I need a total of 3, so I move on to my next given. Now I have 2 sets of perpendiculars, so I'm going to do them both in one step, because I'm probably going to need them both. I have TR and RN, and then I also have HS and IE. Given. So I do a mini proof with those. For perpendicular lines form congruent right angles. So TR and RN meet there. HS and IE meet there. Angle TRA is congruent to angle HSB. All right, I have 2 pairs of things. I need one more. I've got another given. I've got a gift. DH is congruent to AT. Given. Do I have my 3 pairs of things congruent? Yes. So now I can state the triangles are congruent. Again, I always want to prove triangles. Triangle TRA is congruent to triangle HSC. What's the reason? I see 2 angles and 1 side. The side that's marked is not the side that's between the 2 angles. So that's AAS. Now that the triangles are congruent, I can state that any of the corresponding parts are congruent. So I can state that SH is congruent to RT because that's what it wants me to prove. And the reason is CPCTC. You're always proving the triangles are congruent. If you're doing a proof and you did not prove the triangles are congruent, it is not right. You're always proving the triangles are congruent. And after that, you're going to state what they want you to prove, CPCTC. Look at the other examples we did. We're always stating the triangles are congruent, and then after that, what they want us to prove, CPCTC. We're always stating the triangles are congruent, and then after that, what they want us to prove, CPCTC. It's going to always end the same way. The second to last step is going to be the triangles are congruent, and then you're going to state what they want you to prove, CPCTC. This takes a lot of practice. This is very important. So practice it, use the key, use the video. Have a great day.